Hello, everyone. In this video, I'm going to talk a little more about compound interest, but we're going to look at a case now, or several cases, where the compounding is not annual, but could be some other period of time. So let's do an example first, and then we'll see how this example uh, can be used. Um, to calculate formula that's more general than the one that we had for annual interest rates. So um, let's say a student invests in a CD. Um, that's a certificate of deposit at a bank, um, which has a term of 5 years again, 5 years, and an annual or an APR of, we'll say, 8%. Okay. Um, the student's investment, the student buys, or we'll say the student invests $10,000 again. A very well off, student's doing all right. So how much will the student have after 5 years? So how much will the student's investment be worth at the end of the term if the CD A compounds annually, B compounds quarterly, that means 4 times a year, or C compounds monthly. Right. So let's take a look and we'll see how to answer these. So the part A, we have a formula that we've done in the previous video. So the answer here for A is we take the principal, which is we write as P, and we multiply it by 1 plus R to the fifth in this case, to the term. But let's actually, before I write that formula, let's write out what the principal and the rate and the term are. So the principal here is $10,000. The rate is 0.08, and the term is 5 years. Okay, so this formula for A is going to give us, in fact, we can start our answer to A down here because that's not going to change. It's just this formula P times 1 plus R to the T, which is P times 1.08. Pardon me, I'll put in the value for P, 10,000 to make dollars here, to the fifth. And here you're going to want the use of a scientific calculator. We'll just do 10,000 times 1, oops, 0.08 to the 5th. And we'll get our answer. So this is 14,693 and 28 cents. Wonderful. Okay. So this is the answer to A, just applying what we did in the prior videos. Okay, great. However, what do we do for the quarterly compounding? So how will that work? Well, the idea is to do what we did for the yearly the annual compounding in the last video. So we'll say the end of the first quarter instead of first year. How much is the investment paying off? And there, what we have is we have our initial investment, and we're going to say it's going to be 1 plus not the rate. Here in the annual case, it would be rate, but the rate in the annual case is the rate per year. So now we're not going to have the rate per year. We're going to have the rate per quarter. So that's 1/4 of the amount. So at the end of the first quarter, we've only gone through a quarter, not a full year. So we don't get interest applied for a yearly amount for only 1/4. We get the 1/4 of the interest rate applied to the principal. And so this is going to be 10,000 in this particular case, times 1.02, right? Because 0.08 divided by 4 is 0.02. But we can do this again. We can say, okay, well now that's how much is in the student's investment. That's the worth of the investment after the first quarter. What about after the second quarter? Well, they'll have now that amount They'll have that amount. That's the amount that they had, but then they have to apply the interest to that. So they get that. Again, they'll get a 10,000 times 1.02 now squared. And you might be able to see where it's going, but in case you're not picking this up yet, you'll get it in the next one. So let's do one more. Here I'm just going to copy the whole thing, and we'll make some edits here. So now we're at the end of the third quarter. And here we have to apply this interest rate to the prior quarter's amount. And the prior quarter's amount is this squared. And so now what we can do is we can see that we get a 3 here. And you might now see what's happening. So we can see this is the end of the first quarter, end of the second quarter, end of the third quarter. And here are some numbers to pay attention to. The first quarter, well, okay, I didn't write it this time. There's a 1 here. That's 1, 1, 2, 2. Everything else is the same here, 3, so on and so forth. The numbers in the exponents here match up with the number of the quarter that we're in. So what are we going to do? We can say, well, what is going to be the quarter that we're finishing with after 5 years? So there are, let's call it capital T, compounding. in this case. I didn't tell you what that number was. The t equaling, oh my goodness, I'm sorry. There are how many compoundings? Well, there's 5 years and there's 4 compoundings per year. So that's 20 compoundings in this case. So I'm writing this letter T here because that's something that will appear in our formula, and it's the number of compoundings for our situation. So there are 20 compoundings in this case. And at the end of the third compounding, at the end of the third compounding, we had 10,000 times 1.02 to the third. So at the end of the 20th compounding, which is the last of the or quarter, if you will, we will have 10,000 times 1.02 to the 20th. And this is the end of 5 years because there are 4 quarters in a year. So we can compute that. Let's see. Here, this last computation. So we had 10,000 times 1.02 to the 20th power. That's going to equal 14,859 and 47 cents. And that is the answer here. So what we can do now is we can, at the end of B, having learned what we've learned, we can make a new formula and then we'll answer C. Okay. So here's a new formula, general compounding formula. Which is the following. So we need a few new terms. We need this notion of a periodic interest rate. So we'll say let lowercase p be the periodic interest rate. And what is that? That is equal to is exactly R over the number of compounding times compounded in a year. Want to think of it that way. That's a pretty messy looking thing. I think I'm going to bring this whole thing down to a new page so that I can see what we're doing here. And let T, again, be the number of compoundings, number of times we compound. Then the future value is F equaling P, capital P here. Capital P is the principal, as always, times 1 plus lowercase p to the T, capital T. So this looks a lot like the annual case, except we're hiding a little bit. This is not R, and this is not lowercase t. If we wanted to write it in terms of R and T, you would have to say the number of times that you're compounding. So there's another way you can express this, but I think we'll stick to the book's formulation. All right, so where do we see this here in this previous problem? You'll see that this lowercase p is r over 4. So here, our lowercase p is our rate over 4, because the number of times we're compounding in a year is 4 times. That's once every quarter. So this formula applies here to say that the future value, which this is the formula that we would apply here, future value is our principal times 1 plus p to the t. And remember, so the p is 0.02, the t is 20. That's where we got that number. All right, so what if we, now what I would like to do is apply this formula to answer C. So this is, again, a formula you could have in your notes. If you put this formula in your notes, I would really recommend, again, that you also put in what this means, what lowercase p means, so that you don't confuse it with principal or rate, because it's a rate, it's a periodic interest rate. And then put in t so that you know that this t is not lowercase t. This is the number of times that you're compounding. So let's apply this formula, though, to the case where we have the same kind of CD, but it compounds monthly. So the principal is the same. The principal is 10,000. The rate is the same. The rate, or the APR, was 0.08, and the term was the same, was 5 years. So what's different here is that we're compounding every month. So what we need to do is calculate lowercase p, which is the periodic interest. The periodic interest is given here as the rate divided by the number of times compounded in a year. So that is going to be p equaling 0.08 divided by 12, which is equal to essentially 2/3 times 0.0067 times 1/100th. Okay. So this is an I mean, we're approximating. We go 6, on and on, if you will. All right, so this is our P. And what about T? Well, T is the total number of times that we compound. Our T is equal to, I'm going to move this over a bit. Our T is equal to 5 times 12, right? Because we are doing it, our term is 5 years, and we compound 12 times a year. So that's 60. So we've calculated T, and we've calculated P, and the rest is just putting it into a formula. So now our future value is given. Future value, it's given by P, 10,000 times 1 plus 0.00667 to the 60th power. 1,000 times 1.00667, the 60th. And here I will need to go ahead and use my calculator again. So we will go ahead and go here, say 10,000 times 1.00667, all to the, well, that number to the 60th power. It's going to give me 14,901.42. And that is the answer to part C. So the key thing is not being able to enter it into a calculator as much as it is being able to compute the periodic interest rate and the total number of compounding times we compound. Now, if you like, you can compare each of these scenarios, and you'll see that when we compound annually, we get this 14,693. Compounding quarterly gives us 14,859. And then compounding monthly gives us another bump to 14,901. So each time as we are compounding more and more, we are getting a higher and higher amount to our CD. So if you have your APR the same for a single investment, look at the number of times it's compounded. If it's compounded monthly, that's preferable to compounding quarterly or compounding annually, certainly. So that's something to keep in mind. Great. And so in the next video, we'll talk about what happens if you sort of go compound daily and then compound hourly and then compound every minute. And you may want to think, well, what happens if you sort of continuously compound? You know, take some kind of limit in your mind of what would happen in that case. And we'll talk about that in the next video.